Good day, everyone. Today we are going to discuss the basic concepts in statistics. So, what is statistics? Statistics is a science concerned with developing and studying methods for collecting, analyzing, interpreting, and presenting empirical data. Probability is a mathematical language used to discuss uncertain events, and probability plays a key role in statistics. So, what is really the purpose of using statistics? Statistics teaches people to use a limited sample to make intelligent and accurate conclusions about the greater population. The use of tables, graphs, and charts plays a vital role in presenting the data being used to draw these conclusions. Here we have basic terms in statistics. Number one is data. Data are the values that the variables can assume. Data are characteristics or information, usually numerical, that are collected through observation. In a more technical sense, data are a set of values of qualitative or quantitative variables about one or more persons or objects. A single value of a single variable is called a datum. Next, we have variable. A variable is a characteristic that is observable or measurable in every unit of universe. A variable is a characteristic of a unit being observed that may assume more than one of a set of values to which a numerical measure or category from a classification can be assigned. Number three is population. Population is a set of all possible values of a variable. In statistics, a population is the entire pool from which a statistical sample is drawn. A population may refer to an entire group of people, objects, events, hospital visits, or measurements. The last one is sample. Sample is a subgroup of a population. A sample refers to a smaller, manageable versions of a larger group. It is a subset containing the characteristics of a larger population. Samples are used in statistical testing when a population sizes are too large for the rest to include all possible members or observations. Classification of variables. In classification of variables, we have qualitative variables and quantitative variables. Qualitative variables. A qualitative variable, also called a categorical variable, is a variable that isn't numerical. It describes data that fits into categories. Qualitative variables also express categorical attributes. Examples are gender, religion, marital status, and highest educational attainment. Next, we have quantitative variables. A quantitative variable is a variable which can have some numerical value. It can be represented in numbers. Also, arithmetic operations can be performed on these variables. Even after performing operations like addition, subtraction, multiplication, or division, we get some number as the result. Quantitative variables answer questions such as how many or how much. Examples of qualitative variables are height, weight, household size, and number of registered cars. Quantitative variables have numerical values. Meaningful calculations such as average and standard deviation can be made for quantitative, but not qualitative variables. Qualitative variables, on the other hand, can be put in groups or categories. For this reason, they are also called categorical variables. Sometimes they are given discrete numerical values that are convenient for grouping. But these numbers are not useful in doing calculations such as average or standard deviation. Next slide, we have two types of quantitative variables: discrete and continuous. Discrete variables. Discrete variables are variables for which the values it can take are countable and have finite number of possibilities. These are the data that can be counted. Examples are the number of children per family, number of students in a class, and number of citizens of a country. Next, we have continuous variables. Continuous variables are variables for which the values are not countable and have an infinite number of possibilities. Continuous variables are the data that can be measured but not countable. For examples are age, weight, and height. Given the example age, you cannot count age. Why? Because it would literally take forever. For example, you could be 18 years, 7 months, 9 days, 12 hours, 54 seconds, 3 milliseconds, 8 nanoseconds, 9 picoseconds, and so on. Next slide, we have levels of measurement. In levels of measurement, we have nominal, ordinal, interval, and ratio. Nominal. The data can only be categorized. In nominal level is a qualitative variable where no ordering is possible or implied in the levels. For example, the variable gender is nominal because there is no order in the levels female or male. Eye color is another example for a nominal variable because there is no order among blue, brown, or green eyes. Next, we have ordinal. Ordinal. The data can be categorized and ranked. Ordinal level, on the other hand, is also a qualitative variable with an order implied in the levels. For instance, if the severity of road accidents has been measured on a scale such as light, moderate, and fatal accidents, this variable is a qualitative ordinal variable because there is a clear order in the levels. Next, we have interval. Interval. Interval level. The data can be categorized, ranked, and evenly spaced. The interval level of measurement not only classifies and orders the measurements, but it also specifies that the distances between each interval on the scale are equivalent among the scale from low interval to high interval. A popular example of this level of measurement is temperature in centigrade, where, for example, the distance between 94 degrees Celsius and 96 degrees Celsius is the same as the distance between 100 degrees Celsius and 102 degrees Celsius. Last one, we have ratio. Ratio is the data that can be categorized, ranked, evenly spaced, and has a natural zero. In this level of measurement, the observations, in addition to having equal intervals, can have a value of zero as well. The zero in a scale makes this type of measurement unlike the other types of measurement, although the properties are similar to that of the interval. Level of measurement. For example, the number of siblings, weight, and height. Lastly, we have 4 basic methods of sampling. In 4 basic methods of sampling, we have random sampling, systematic sampling, stratified sampling, and cluster sampling. In random sampling, this is done by using chance or random numbers. Random sampling is a reliable method of obtaining information where every single member of a population is chosen randomly merely by chance. For example, in an organization of 500 employees, if the HR team decides on conducting team building activities, it is highly likely that they would prefer picking cheats out of the bowl. In this case, each of the 500 employees has an equal opportunity of being selected. Next, we have systematic sampling. This is done by numbering each subject of the population and then selecting ninth number. Systematic sampling is to choose the sample members of a population at regular intervals. It requires the selection of a starting point from the sample and sample size that can be repeated at regular intervals. Next, we have stratified sample. If a population has a distinct groups, it is possible to divide the population into these groups and to draw SRS from each of the groups. Stratified sampling is a method in which the researcher divides the population into smaller groups that don't overlap but represents the entire population. While sampling, these groups can be categorized and then draw a sample from each group separately. Last one, we have cluster sampling. This method uses intact groups called clusters. In cluster sampling, the population is first split into groups. The overall sample consists of every member from some of the groups. The groups are selected at random. So that is the end of the discussion. I hope you learned something. Thank you for watching.